Hi, I'm Luis Marques, and this is a poster about work I did at low risk. I'll explain how, with a surprisingly simple tool, we were able to rapidly identify, isolate, and fix a whole range of code generation issues. As LLVM's RISC-V backend started to mature, we began to put more effort into ensuring it generated high-quality code. The way I originally did this was by looking at benchmarks, seeing what kind of code was being generated and how it compared with the code generated by other compilers. This was a slow and laborious process, but it did allow us to identify some things to improve in the backend. A big problem with this approach is that it's easy to miss certain code quality issues because they don't occur frequently or they just become buried in a mountain of optimized code. For instance, one day I noticed that we were generating poor code for a simple expression. This only became obvious when I looked at the code in isolation. So I realized that we could be missing similar issues, but I wasn't going to find them by looking at benchmarks. I needed a new approach. The approach I took was to write a simple tool to do differential analysis of the code generated by Clang and GCC. This isn't a new technique, but it works so well for us that I wanted to share it with you. The idea is that we randomly generate C code and we compile it with both Clang and GCC. Then we look at the output assembly and try to automatically determine if Clang generated poor code by seeing if GCC had a better alternative. I implemented this functionality the simplest possible way that could work. For the code generator, I wrote a simple recursive descent generator which directly emits the code without building an AST. Initially, it just generated a function that returned a random expression. Later, I added some more constructs, like loops. The generator is quite simple, but we can easily customize it so that it's more likely to generate programs that find code gen issues in the backend. For instance, when we generate an integer literal, we don't generate all numbers with equal probability. We use our knowledge of the RISC-V ISA to efficiently explore ranges of numbers that are handled in a different way by the backend. The tool then compiles the randomly generated code with both Clang and GCC. To estimate the quality of the generated code, the tool currently implements a very simple cost model. It parses the assembly code, assigns a cost to each instruction, and it just adds up all of the costs. The individual costs depend only on what kind of instruction it is, like load store, an integer operation, floating point, and so on. These proved good enough to detect issues that we care about, so we haven't yet needed to replace it with something a bit more sophisticated. Finally, the tool just checks if Clang produced worse code than GCC. If the total cost is larger for Clang than for GCC, then we record that test case. Otherwise, we throw it away and start again. For the cases we keep, the tool runs C-reduce to minimize the program, and then it saves a description with everything we need to reproduce the issue. When C-reduce runs, it uses this cost comparison pipeline, so it only accepts source simplifications that preserve the cost difference originally detected. As I said, this technique of differential analysis isn't new, but the work and the results were just so satisfying that I had to share them with the community. It took less than a day's work to get a basic version of the tool working, but that was enough to immediately identify a lot of issues. With a few more days' work, improving the tool and triaging the saved cases, we detected code quality issues that span multiple categories. For example, using too many instructions to materialize constants, having unnecessary sign extensions, or using branches when we could use comparison instructions. In some cases, we weren't using the offset immediates in load and sort instructions. There were also unnecessary floating point conversions, and even cases with dead instructions. Many of these issues we have already addressed with simple fixes. Other issues require more complicated solutions, so we still have a backlog of issues to work through. What I want you to get out of this poster is that this is a straightforward technique, but it can be highly effective, so it's something that you may want to try too. Thank you.